you start to panic, then you take a deep breath and think, oh, if in doubt, let's just plug in all the equations. We got 8 possibilities here because we got 4 equations, and then we got horizontal and vertical. So let's plug them all, see what pops out of it. So if I plug into the first one here, let's just do what is currently labeled as j hat. We've got 135.6 equals 30 cosine theta times time minus 4.435 times squared. Plugging into the second equation, we got 135.6 is equal to, oop, that is wrong. Plus 0, horizontal. Then we have 135 is equal to 30 cosine theta plus v final divided by 2 times time. We've got v final is equal to 30 cosine theta plus 0. And then the last one, final speed squared is equal to the initial speed squared plus 0. In and of itself, they're not independent of each other. You can't really solve for the 3 unknowns given these 4 equations because they are not independent. Because if we take the square root of both sides here, we basically get that. I'm ignoring the plus minus issue. And this ultimately would boil down into that. But let's get our I hat equations. Let's plug the vertical in. I got negative 40 equals 30 sine theta t minus 4.435 t squared. Negative 40 is equal to 30 sine theta plus v final divided by 2 times time. V final is equal to 30 sine theta plus negative 8.87 t, and v final squared is equal to 30 sine theta squared plus 2 times negative 8.87 times negative 40. In and of itself, this is not enough to solve it, but we do have some combination here. Again, we're trying to solve for theta. Which 2 equations would be the, I'll use the term loosely, simplest ones to use?
Probably the top ones.
What's wrong with using any of the other 6?
Well, they involve v final, which we don't know. And they're not the same either. Yeah.
That is true, yeah. So this would be, call that FJ, FI.
Well, not necessarily the same, at least.
Yeah. Odds are against it. All right, so if we use the first 2 equations, we have 2 equations, 2 unknowns. Now it's just a matter of how do you actually solve 2 equations, 2 unknowns when trig functions are involved. Let's see, I'm gonna get rid of most of this and we'll start working out over here. When you write the 2 equations over here, I got 135 point, let's see. $135.6 is equal to 30t cosine theta, and negative 40 is equal to 30t sine theta minus 4.435 t squared. That is absolutely horrible. T squared. All right, those are our two equations. I'm going to get rid of everything else. Oh, is it? There we go. All right, given our two equations, how do you solve it? Two equations, two unknowns.
You could solve one for t and then substitute.
All right, which one should we use to solve for t?
Top one.
I think that'd probably be simpler. There's another problem where you end up with equations like that, and I actually ended up solving for t in the second one, plugging it into the first one. It just took a whole lot longer. Why did I do it? It made sense at that moment, not afterwards. All right, so if we do the first one, so I have t is equal to 135.6 divided by 30 cosine theta. So now, let's plug it into the second one, so I now have negative 40 equals 30 times 135.6 over 30 cosine theta, sine theta, minus 4.435 times 135.6 over 30 cosine theta squared. Now what? I will say, and I think my email to you, I talked about the leap of faith. There's,
You said that you like multiply or use the least common denominator there, right?
yeah. I mean, there's a certain amount of leap of faith that you're doing it right, because you're about to venture into potentially a lot of work. And so you have to assume, I'm doing it right, I'm gonna get an answer. Because I think a number of students in physics get to a certain point, they're going, I don't even know if I'm doing it right. Do I really want to spend the next hour on something that's wrong? Multiplying by the least common denominator is, sure, let's do that. There's a different way of doing it, but this is the longer, more fun math way. First off, let's just deal with the numbers here. So I've got that and that. Don't forget to square these things. So I've got negative 40 equals, what is this?
1.
Oh. I assume you were about to say that.
Yeah.
Sine theta over cosine theta equals, and then this over here, no, not equals, minus.
So 135.6 to the power of 2 multiplied by 4.435 divided by 30 is...
30 squared. Did you square the 30?
Oh, no, I didn't.
90.6. Just in the one decimal.
90.6,
No, so got
6.1.
6.1, okay. All right. Multiply by the LCD.
I guess multiply that left one top and bottom by cosine theta. To
Oh.
make the denominator cosine squared theta.
Okay. So negative 40. Let's go for a brighter color. negative 40 equals 135.6 sine theta cosine theta divided by cosine squared theta. I guess now we have a common denominator, minus 90.61. Now what?
I guess multiply the denominator to the left side.
All right, so we got negative
Both
40
sides to make it on the left.
cosine squared theta equals 135.6 sine theta cosine theta minus 90.61. Now what?
I'm sure there's some trig identities that can at least help.
True. And just in some fairness here, when I worked this problem out and the way I presented in class the first couple times, I did it this exact same way. And then a student pointed out a nice simple trig identity that I had missed. Go look up the trig identities.
Yes.
What's the primary one with sine and cosine?
Sine squared plus cosine squared equals 1.
Yeah. I'm just gonna make a note of that over here. All right, to solve this, we could get it in terms of cosine of 2 theta and sine of 2 theta. That's not gonna help us in this particular case, unlike the other problem. What you need to do is you need to get sine theta isolated, or either sine or cosine isolated. Probably sine isolated, so if we did that, we'd get 90.61 minus 40 cosine squared theta divided by 135.6 cosine theta is equal to sine theta. Square both sides. Sine squared theta, what is that in terms of cosine?
Cosine minus 1. 1 minus cosine.
So this will be equal to 1 minus cosine squared theta. And this, you'll have a cosine to the 4th power. What you'll end up happening is you'll have a cosine to the 4th power. I think the 3rd power term drops out. And so you'll have a cosine to the 4th, cosine squared, and a constant term. Use quadratic formula to solve for cosine squared, and then take the square root of both sides. You'll end up with 4 solutions, of which 2 of them are not valid.
How do you get cosine on the bottom with a 135.6?
I'm trying to isolate sine, so first I get rid of that hanger on, and then I divide by the 135.6 cosine theta here. Is the question how I got cosine here?
No.
Okay. Sorry, do you see this now?
Yes.
Okay. And as much fun as it is to keep going on this one, there's a temptation, but I'll bombard you with more math than you want at another point. Oh,
Thank you. I'm not gonna remember all this.
or Patrick, since you actually brought this up, do you want to continue doing this method, or? Okay.
I gave up on my version and just started brute forcing it, like you said.
Oh, yeah. All right, if we take this equation right here and divide everything by cosine squared, what do we get?
Get sine over cosine squared plus 1 is equal to 1 over cosine squared.
All right. What's sine squared over cosine squared?
Tangent squared theta. Squared theta. tangent squared theta.
Absolutely. So we get tan squared plus 1 is equal to 1 over cosine squared. So if we come back over here, I got sine over cosine, that's just tangent. Don't get the least common denominator. So let's go ahead and lasso this stuff. So we end up with negative 40, and it really helps if I'm writing something. Negative 40 is equal to 135.6 tangent of theta minus 90.61. Is it 90.61?
Yeah.
Times 1 over cosine squared theta. This, by the trig identity over there, is just 1 plus tangent squared. So I get 135.6 tangent of theta minus 90.61 1 plus tangent squared. Negative 40. I don't have theta isolated by itself, but I have tan theta. I can solve for tan theta first, and then from that, I can solve for theta. So just for the sake of simplicity, I'm going to let x equal tangent of theta, or pick a letter. I guess I'm using x over there for something else, so let's make this p. P for tangent of theta. So I have negative 40 is equal to 135.6p minus, distributing, 90.61 minus 90.61p squared. Now how do we solve this?
Quadratic, right?
Yep. I got a second order polynomial. Getting everything over onto the left-hand side, I have 90.61p minus 135.6p plus 50.61 equals 0. Get a minus sign screwed up here. All right, I think that's looking good. And so p equals 135.6 plus or minus the square root of 135.6 squared minus 4 times 90.61 times 50.61 divided by 2 times 90.61. We will get 2 answers. Do you look something else up? Or do you have did you get 2 answers? Anyone?
Oh, sorry. Which one's the squared? Which one's A?
That's A, B, and C.
Oh,
Did I mess up somewhere, or?
I just didn't see a P squared.
Oh, that should be squared there. Thank you.
I got like 0.7849 and 0.7115.
Yeah. I got the same.
All right. So, that is equal to tangent of theta, so therefore theta is the arctangent of these. And so we end up with
38.1 degrees and 89 or 90 degrees, 0.0.
90.0.
90.0 degrees.
No, I am not buying that. You did the arctan of 0.7115?
Yeah, or, no, 7,100.
Okay.
There, 35.4 degrees.
And what do these numbers mean?
So if I'm at the top of the cliff, throwing it at 30 meters per second.
Yeah.
Now, we do have some rounding. If we take it out more decimal places, one of the answers should have been 37 degrees. But there are two different angles at which I can throw this to get it that same distance.
Oh,
One of which will go like that, and there's one that's a little bit smaller that's gonna have more of a horizontal component to it, less of a vertical, but it's gonna be more like that, and hit the
Right.
exact same spot. If we ended up with a negative angle as one of the solutions, then that meant that there's one solution where it could be thrown in that direction to hit the same spot. So, this I consider to be the hardest of projectile motion problems. The only difference between this and any other projectile motion problem is what you're given and what you're not. Questions?
will this be on the test?
Oh, yes, there will be a projectile motion problem on the test.
Oh, the one where we need to find two angles to give us a similar point of impact?
It depends upon my mood when I'm writing the test. The way I write the test is I take one of the old tests, I just randomly pick one. Basically, I close my eyes and move the cursor up and down, and then I click whichever folder it lands on, that's my starting point. I take that test,